For this lesson, we're going to look at proving triangles are similar. With that in mind, we're given some theorems and postulates, so let's look at the first one. The angle-angle similarity postulate states if two corresponding angles are congruent, then the triangles are similar. So, looking at the picture here, I have corresponding angle B and R and congruent, and I have corresponding angle A and P congruent. So I'm going to go angle A is congruent to angle P, and angle B is congruent to angle R, and angle C, therefore, is congruent to angle Q, because if two angles in a triangle are congruent to two angles in another triangle, then the third angle is also congruent. That is an earlier theorem. So now I have the congruency, and my angles are corresponding, so I can make a congruency statement that my similarity statement. So triangle ABC is similar, remember that's what that symbol means, to triangle PRQ. Make sure you're matching up the corresponding pieces. And my statement of proportionality, basically all my sides are proportional. So the length of AB is to PR as the length of BC is to the length of RQ, which is also the same as the length of AC to the length of PQ. Okay? So now, using that information, are the triangles similar? If so, write the similarity statement. So the first thing I have to check is, are there two corresponding angles that are congruent? Well, this figure, both triangles share angle A. So angle A is congruent to itself. And then F and E are congruent because they are right angles, and all right angles are congruent. So I have congruent angles, two pairs of congruent angles, corresponding angles. That means the triangles are similar. So my similarity statement would be triangle AED is similar to triangle AFC. Okay? In the next figure I'm looking at, I'm going to note that these are both 40, so angle X is congruent to angle O. And then I note that I have two different values here, so I need to find that third value. So 180 minus 40 minus 72 is 68. And 180 minus 40 minus 68 is 72. So you can see that my angles are all matching up. So I have two pairs of I have two pairs of corresponding congruent angles, so my triangles are similar. So my similarity statement would be triangle XYZ is similar to triangle OPR. And again, it helps me to use the colors to make sure I'm matching up the corresponding pieces. So the next thing it says, use the figure in example 1 and list all pairs of corresponding congruent angles. So here's the figure 1. I have actually already identified two pair. Angle A is congruent to itself, which is the reflexive property. Angle E and angle F are congruent. Angle E is congruent to angle F. That's because they're both right angles, and all right angles are congruent. And then angle C and angle D are the other pair of corresponding congruent angles. Okay. Now, looking at these triangles, we're going to identify if they are indeed corresponding. If the triangles are similar. I'm supposed to find the missing pieces. So they tell me the triangles are similar, so I'm finding x and y. So the first thing I need to note is that this is vertical angles, so 40 degrees here is 40 degrees here. And then these are parallel lines cut by a transversal, so alternate interior angles are congruent, so that's 55 degrees there. And then 55 and 40 minus 180, right? So 180 minus 55 minus 40 gives me that this angle right here is 85 degrees. And I have parallel lines cut by a transversal. Parallel lines cut by a transversal. That would be this right here. Whoops, that's terrible. The alternate interior angles are congruent, so that means angle, that x is 85 degrees. So 1 down, x is equal to 85 degrees. And then I need to find y, so I need to set up a proportion. So my not marked side, the smaller to the bigger, so 8 is to y as 3 is to 5. Setting that up and setting it equal to each other. Remember, my cross products are equal. So 8 times 5 is 40, and 3 times y. So I'm going to have 3 times y equals 40. And I'm going to divide by 3. And I'm going to get that y equals 40 over 3. If you change that to a fraction, it'll be repeating. So I'm sorry, if you change it to a decimal, it'll be a repeating decimal, so I'm just going to leave it like that. Okay, looking at this problem right here, again, I know that the triangles are congruent. It tells me that, so then I have to match up the correct pieces. So I can see that this is a right angle, and these share this right here. So my triangles, this piece corresponds to that one. And then the hypotenuse, this piece corresponds to the hypotenuse of that triangle. And then my third side is the yellow right here. So those are similar triangles. I can write a proportion. So the first one I'm going to do, I'm going to find x. So the 8 is to x as the 10 is to y. Oops. As the 6 is to 9. I want to use the numbers, not the other variable. So multiplying across, I get that 6x equals 8 times 9, so 6x equals 72. Dividing by 6, I get that x equals 12. So that's one variable. Then the other variable, again, I'm going to use the 6/9 because I know that that ratio holds for the triangle. And then I'm going to say 10 is to y minus 12. So now I have my other variable. Using my cross product property, I'm going to have 6y minus, let's just write it as 6 times y minus 12 is equal to 9 times 10. So 6y minus 72 equals 90. Moving my 72 over, 6y equals 162. Dividing by 6, I get that y equals 72. Okay. Moving on. Let's try a real life potential example. So Miguel uses a shadow of the flagpole to estimate its height. Miguel is 6 feet tall, and he stands at point E, 10 feet from the base of the flag. So he stands here, he's that far away, and his shadow is 5 feet long. So his shadow is going to hit from here, and you're supposed to find CD, the height of the flagpole. So you should be able to see that you have two corresponding angles that are congruent. This is congruent to itself, and then I have two right angles. So my triangles are similar, so I can set up a proportion. My proportion would look like, I'm going to call this F, instead of CD because it's the height of the flag. Then I'm going to say that 6 is to F as 5, this piece is to the whole piece. 5 is to 15. Be careful here, it's easy to just write 10 and get confused. You need the whole length of the side. Then I'm going to multiply, use my cross products. So 5F equals 90, and then I'm going to divide by 5, and I'm going to get that F is 18 feet. So the flagpole is 18 feet tall. Okay. Now, again, looking at the theorems we have, so the first one we've already looked at, the angle similarity postulate. We've used that a few times. Then we also have the side similarity theorem, which says if the corresponding sides of two triangles are proportional, then the triangles are proportional. So when I look at this, I see that I just need to match my sides up. So 8 and 4, I have 5 and 10 and 5, and 12 and 6. And you can see that those all equal 2. So my proportionality holds, so these are similar triangles by side similarity theorem. Over here I have the side similarity theorem. This one says that if I have an angle of one triangle congruent to the angle of another triangle, the sides including the two angles are proportional. So if that's true, then the triangles are similar. So basically what it's saying is I have congruent angles here. J and B are congruent. If A, B, and J, G has the same proportion as BC and JH, then I have similar triangles. So is 2 over 4 going to be the same as 3 over 6? Well, yeah, they both reduce to 1/2. So again, I have a proportional or similar triangles there. Okay, so now we're going to use that information to write similarity statements. So write the similarity statement for each pair of triangles and explain why they are similar if requested in the problem. Solve for X and Y. So starting with this first one, I'm looking at this. Notice that there's a piece of information missing. Those are parallel lines. Because these are parallel lines, I have this cutting across my triangle. It's making my angles here the same, and they already share A, so I know I have by A similarity postulate. I have the triangle ACB is similar to triangle AED. Okay, and then to find X and Y here, I'm going to do 8 is to 10 as 12 is to Y. I'm going to get 8Y equals 120. So then Y equals 15. And then looking at X, I'm going to get that. I'm going to use that 8 and 10 again. I'm sorry, I'm going to use that 8. I'm going to use 8 to 12. This side is to the big side. 8 is to 12 as 7.5 is to X plus 7.5. I want to go back here real quick. This ratio could have also been 8 is to 12 as 10 is to Y. And I want to remind you that your means can be exchanged. So these both work. This is the proportion or the ratio I want to use for this problem, so I'm keeping it consistent. So now I'm going to multiply this across. I'm going to have 12 times 7.5. Oh, let's just write it out. 8 times x plus 7.5 equals 12 times 7.5, and that's going to give me 8x plus 60 equals 90. Subtracting the 60, I get 8x equals 30. Dividing by 8, I get that x equals 38, or 15/4. Either of those works. So there's my other variable. Okay, going on to the next problem, I have that my triangles to check. I don't have any angle information, so I need to really check to see if the proportions hold between the sides. So is 7.5 over 3 and 15 over 6 and 10 over 4. Do those all produce the same value? This is 2.5, this is 2.5, and this is 2.5. So yes, they are. This is two similar triangles. This is by side, side, side. I wrote this backwards over here. This is by side, side, side. Similarity theorem. And my similarity statement would be the triangle XYZ is similar to triangle OTJ. Okay, looking at the next problem, I have angle A in this one at BAD is congruent to C. They tell me that. So the top of this triangle and the top of that one. And then they both share angle D. So these are definitely similar triangles by the angle similarity postulate. The similarity statement would be that triangle ABD is similar to triangle CAD. Alright, now on to our next one. I have vertical angles. So I know that if I have an angle, that if the relationship of the sides is proportional, then the triangles are similar, right? If the ones that enclose it. So here are the sides. Those would be corresponding, and these would be corresponding if this works. Then I check the proportion is 3.2 over 9.6 equivalent to 1 over 3. Well, this is 1 over 3, and that is still 1 over 3. So yes, this is proportional by the side angle side similarity. So my similarity statement would be triangle SRE is similar to triangle ORT. And then I would look for my missing variable. So I have 3.2 is to 9.6. Actually, I'm going to use 1 and 3. I have 1 is to 3 as 2.8 is to x. Then I'd cross multiply. I'm going to get that x equals 3 times 2.8, which gives me 8.4. All right, let me know if you have any questions.